Hello everyone, welcome to ArcGIS tutorial series. In the last time tutorial we have discussed about the interface of ArcGIS and I hope you found it helpful. In our today's tutorial we will see how to work with vector data in ArcGIS, which is the second tutorial of ArcGIS tutorial series on this channel. But before diving directly into today's tutorial, we must be clear with the meaning of vector data model and its types. So vector data in GIS is a type of data model which represents features on the surface in a point, line, or polygon. That means to represent a data associated with a single location in space, we use a point data. To represent a feature described by a string of spatial coordinates, we use a line data model, whereas to represent aerial features which are described by a closed string, we use a polygon data model. So now let's add some vector data into our ArcGIS environment and see how to perform different operations with it. But before that, guys, I am recording this tutorial outdoor, not in the house, so that I apologize for a noise or a poor sound quality. In ArcGIS, we can add any GIS data through this plus tool in the standard toolbar, or you can go to File, add data, and add data here. And to add data we have to navigate to the place where our vector data is saved. To do that we use looking drop down menu and connect to the folder where our data exists, or click on connect to folder icon over here, connect to folder, and then connect to the folder where our data is found. My data is found in downloads. It is database ETH. Here, for demonstration purpose, we are going to add vector data models of three types: a vector data, a point data model, a line data model, and a polygon data model. So let's add them one by one. Okay, after connecting, say okay, then it's already connected actually. Now this one is the vector data of type point, it is major towns. So add, as we can see here, after adding immediately, the add layer is displayed on the table of contents window here. So let's add a line feature also to go to back up one level, and then this one is a line vector data, I think. But this file is a shape file. Is this shape file? Here our line comes. Add another third polygon data. So here, for demonstration purpose, we have added the three types of vector data: the data with point, line, and polygon features. So after adding, automatically the added data layer automatically appears in the table of contents window, as you can see. So now we can change the properties of the symbol appearing here. So we can change, for example, the symbol for Etio major town by clicking over the symbol assigned for the major town. We can change the color if you want. For example, if I change it to red and increase size to 6, okay, yeah, automatically the data is changed. And again, doing the same for tutorials, the line point data, the line data module. We can change this in color as well. The widths, we can increase the widths. Let's increase the width to 3 now. Yeah, as you can see, the line is increased. Let's decrease this one a bit. Decrease it to 3. Yeah, cool. Now for the polygon features, we can make it hollow, and we can increase outline widths to 2 and say okay. Yeah, it's our data. As you can see, the major towns is important data type, railway, inline, and the region boundaries are in polygon feature. After adding all the data types for better visualization, we can zoom in, we can zoom out, and we can see the full extent of the features. We can also do the fixed zoom in, fixed zoom out. Okay, now for example, if you will zoom in the area, this area for example, by holding the left click and dragging the rectangle over it, and zoom in to see the detail of the data. We can zoom out as well, as you can see. Yeah, and we can also see the full extent of the data layer like this by clicking over this. More importantly, we can move our added data around by using pan. For example, by clicking over this tool and holding the left click, we can move our data layers around as we want. Now we have added our vector data successfully. However, we need to explore more information about the data displayed over here. That can be obtained by right clicking over a layer in table of contents window. Just right click over the layer and then open attribute table. As you can see, the attribute table of ETH major town contains many information. A town name called Rama. Click here, and then as soon as we select this town called or named Rama, the town is automatically highlighted in the map space of our ArcGIS environment, and we can see many informations about the town. To remove the selected feature or to clear the selection, click on the clear selection icon here. Click selection. Yeah, the selection is automatically cleared and no selected features. Yes. But sometimes we may not get a full information about the features we want. In this case, we can add any information by clicking on drop down menu over the table options. Click on drop down menu here, and we can add a field. For example, the field name, for example, the area, town area. If you want to add information about the area of the towns. We can name it area, the type short integer, let's make it yeah, let's keep it default and okay. As we can see, the field named area is displayed over here, and we can calculate the geometry of these features later, and we can also remove the field added if you no longer need it. Okay. We confirm delete field, yes. So I would also like to strongly recommend you that in case you need a quick information about a certain feature, you can use identify tool. Identify tool is designated as I over here. Click over it and then select or click over the entity or the feature you want to know about. For example, if I want to know about this feature, I will click over it and I can get an information here, a brief information about that feature. Here the town name is and the shape is point. The town name is the Terros Katama, and the population is this Warada region, and even the rain, the soil, erosivity, elevation. Here the information which exists in table of content is also so the identify tool is very important in case you need an information about a certain feature quickly. In ArcGIS we can also label the features displayed over the ArcGIS working environment. Labeling is displaying the geographic entity or feature along with its name or information or its certain characteristics. So to do that, right click over the data layer, the data layer, go to properties, to that click on labels, and then check the box label features in this layer, and then the same way, okay, keep it its default as it is, and then the label field, you can choose the label field. The name is always common in labeling the features. Labeling features by its name is also always common, and you can change the style of the text, the style and the font of the text as you want. The style, for example, you can change it to Arial black, Arial narrow. For example, let's make this one, and let's increase the size to 11, and we can even make it bold or italic or underline. Underline is not recommended actually. You can make it italic and then apply. Okay, here the features, the point features are labeled with their name, as you can see. To click the label, we can go back to the layer, right click, properties, and tick this one, label features in this layer, and then apply. Okay, here the label disappears or the label is cancelled. Many geoprocessing tasks can be carried out in ArcGIS environment, but in this particular tutorial we will see geoprocessing tools like clip, buffer, and merge. Before starting, it is better to know what each geoprocessing tools do for us. So to know the functions of each geoprocessing tools, we can hold our mouse cursor over over it for a while and get a brief information. For example, buffer. We can hold our mouse cursor over it and we can get a brief information about buffer. Buffer, for example, is a geoprocessing tool that creates a buffer polygons around input features to a specified distance. And clip is a geoprocessing tool that extracts input features that overlays the clip features. And again, intersect, union, merge is a geoprocessing tool that combines multiple input data sets of the same data type into a single and new output data set. You can get geoprocessing tools from geoprocessing window here, or from Arc Toolbox. Arc Toolbox, which is found in standard toolbar, or simply we can search using search panel. Okay, you can get geoprocessing tools by search panel. Search. You can search for geoprocessing tools you want. For example, buffer. And perform our activity by simply clicking over it. Now input features will be ETH rails. Now output features is named by default ETH rails buffer 3. I've tried 3 times and this is my third. That is why it's named the output feature ETH rails buffer 3 by default. And the buffering distance, let's say it's 6 in meters, and then okay, here the buffer geoprocessing task is being conducted. Yeah, buffering is successfully buffered. Okay. Now let's see the as you can see here, the ETH rails is buffered to the distance of 6 meters to each side. As you can see here, to the right and to the left, it is buffered by 6 meters. This is what buffering is, full extent. And let us do another clip feature over one of the regions over here. Clip, for example, ET pin attribute. Select one of the regions. For example, select region Afar. For example, here if I went to clip the selected or the highlighted region from the whole country, I can perform it from using clip. The input feature will be ETRM1 and the clip feature will be also ETRM1, and the selected or the highlighted region boundary will be clipped out from the whole country, and the clip is now undertaking. Here the clip is successful. So now as you can see, the region called Afar is clipped out of the country, and if I deselect this one, Afar region will be displayed along from the. If I select again, Lastly, let's do the merge geoprocessing tool. Using merge geoprocessing tool, we can combine two adjacent data sets with the same data type. For example, polygon with polygon, line with line, and so on. So now let's combine, or let's merge these two polygons which are near to each other. So if I want to merge them together, I need to go to the merge tool in geoprocessing, and I have to select the two data sets, ETH clip 2 and ETH clip 4. Okay, yeah, merge it together. Select this two. We can, yes, here's the two different regions are merged together. So guys, this is all I have for you today. See you in the next video tutorial. Till then, bye bye.